An AI decides who gets a job. Another AI recommends who receives a life-saving organ transplant. One flags you as a potential fraud risk, and another determines whether you are likely to reoffend and should be denied bail. Now imagine trying to ask why. And the answer is we don't know, not because no one asked, not because no one cared, but because the AI itself doesn't know how to explain it. This isn't a glitch or an exception. It's a fundamental issue at the heart of modern artificial intelligence. You're watching TechnoAIvolution, where we unravel the biggest questions surrounding emerging tech. Without the hype, without the fluff. And today we are tackling one of the most misunderstood, yet critically important issues in AI. Why some of the smartest machines we've ever built can't explain their own decisions. From credit scores and courtrooms to cancer diagnosis and autonomous weapons, when AI makes decisions, we expect answers. But the truth is, those answers might not exist in a human sense. Let's unpack the problem, where it comes from, why it matters, and what we can do about it. When we talk about a black box in AI, we are not referring to physical devices. We are talking about a system where inputs go in, outputs come out, but the inner workings are opaque, especially to humans. This is particularly true with deep learning models like neural networks used in image recognition, language processing, or decision making. These models are made up of layers, sometimes hundreds, of synthetic neurons, adjusting weights and connections based on patterns in training data. Sure, in theory you could trace each numerical calculation, but in practice you're looking at a tangled web of millions of variables. The path from data to decision becomes so complex, it's incomprehensible even to the people who built it. In other words, we are building machines whose logic we can't always follow, and in some cases that's dangerous. Let's ground this in real examples. In the legal system, predictive policing tools are used to allocate patrols or assess risk. One high-profile case involved a system called Compass, used in US courts to assess the likelihood of a defendant reoffending. Judges used it to inform bail and sentencing decisions. But a 2016 investigation found that Compass disproportionately labeled black defendants as high risk, without transparency into why or how it was making those predictions. Then there's healthcare. A study from 2019 showed that a major healthcare algorithm used to allocate medical resources was biased against black patients. Why? Because it used past healthcare costs as a proxy for need, ignoring the fact that black patients often receive less care due to systemic inequities. In hiring, AI tools have been used to scan resumes and rank candidates. But if the training data reflects past hiring practices, say, favoring men for engineering roles, the model might learn to mimic that bias. And when you ask why the AI made a particular choice, the answer is often, we're not sure. Let's be fair, no one set out to make AI unexplainable. But the nature of how we design AI today has led us here. The most powerful AI models like large language models, convolutional neural networks, and reinforcement learning agents are not programmed in the traditional sense. They're trained. You don't tell them how to detect fraud or recognize a cat. You give them huge amounts of data and they learn statistical patterns that map inputs to outputs. It's like raising a very alien child. You say, here are a million examples. Figure out the patterns. And it does. But then you ask it to explain itself and all it can really do is point to a complex soup of weighted math. Humans want meaning. AI operates on math, and that mismatch creates the black box. Even with tools like Lime, Shape, and Saliency maps, we're often not getting real explanations. We're getting interpretations like shadows of meaning projected onto an opaque system. Now here's a twist. Not every black box is inherently bad. In some applications, say recommending YouTube videos or optimizing ad delivery, explainability may not be critical. A wrong suggestion doesn't carry much risk. But in high-stakes environments, healthcare, law, finance, public safety, the ability to explain a decision isn't just a bonus, it's a requirement. If you're denied insurance, a loan, or medical treatment by an algorithm, you deserve to know why. And from a legal perspective, explainability ties into concepts like due process, accountability, and ethical oversight. Black box models can reinforce inequality, automate discrimination, and erode public trust, especially when they appear neutral on the surface, but carry all the biases of the data they were trained on. So, what can we do? There's an entire field now called Explainable AI, or XAI, focused on making these systems more transparent and accountable. Some approaches involve designing inherently interpretable models, ones where the reasoning process is built to be human-readable. Think decision trees, linear models, or rule-based systems. The downside? They often lack the power of deep learning when it comes to complex tasks. Another approach is post hoc explainability, adding tools to interpret a model's behavior after the fact. These include heat maps that show what parts of an image an AI focused on, feature attribution scores that rank which variables mattered most, and example-based reasoning, where the model points to similar past cases. But these explanations are approximate. They help us guess at the AI's reasoning, but they're not definitive answers. Then there are hybrid systems, where interpretable models are used to monitor or verify the decisions of a black box model. Sort of like having a lawyer explain what your AI doctor just did. We are also seeing increasing calls for algorithmic audits, regulatory frameworks, and model documentation. These are ways to track and report how AI systems are trained, what data they use, and how they perform across different groups. The truth is, as AI grows more powerful, the black box problem isn't going away. If anything, it's getting bigger. Foundation models like GPT, image generators, autonomous systems, they're not getting simpler. They're getting more complex, more capable, and harder to unpack. But that doesn't mean we're powerless. We can choose to design with accountability in mind. We can demand transparency in the systems that govern our lives. And we can balance performance with responsibility, knowing that in some cases, a model that explains itself is better than one that performs slightly better but leaves us in the dark. Because at the end of the day, trust in AI isn't just about accuracy. It's about understanding. And we can't understand what we can't see. Thanks for watching. If this made you think twice about how much control AI has and how little we often understand about its decisions, hit that like button. And if you want to keep exploring the strange, fascinating, and sometimes unsettling edges of technology, make sure you subscribe to TechnoAIvolution and turn on notifications. Because the future's being automated and we'd better know what's going on behind the curtain. Until next time, stay curious, stay skeptical, and don't trust a black box without asking why.